In today's video, we're going to solve equations through multiplication and division. So again, we're trying to solve for each variable in each equation. In the first equation, we have r connected to 3 by multiplication. To undo multiplication, we divide. So we're going to divide both sides of the equal sign by 3. The 3's are going to cancel, and we're going to get r equals 5.1 divided by 3. How many times does 3 go to 5.1? We'll find out. 3 goes into 5 once. I get 3. I get 21. 3 goes into 21 7, so 1.7 times. Now we can always check our work. 3 times 1. We'll put our check in a different color. 3 times 1.7. Does that equal 5.1? And yes, it does. So we can always check our work when solving equations. The next we're going to look at is v divided by 4 equals 8. Well, v and 4 are connected through division. So to undo division, we're going to multiply by 4. And multiply by 4. The 4's on the left side are going to cancel. And we'll get v equals 32. Again, we can check our work. V is 32. 32 divided by 4 is, of course, 8. So that checks out. All right, the last one we're going to look at, the last one in this section we're going to look at is 5/13 t equals -9. How are 5/13 and t connected? I am going to say they're connected through multiplication. They are connected through multiplication. How I'm going to undo the multiplication is I'm going to divide by 5/13, which will cancel. Whatever I do to one side, I'm going to do to the other side. Now again, I'm going to rewrite this. So I got t equals -9 divided by 5/13. How do I divide? I have to make them both fractions, so I put 9 over 1. Then I'm going to reciprocate and multiply. So I get t equals -9 first times 13 fifths. And 9 times 13, I need to do it on the side of my paper. You might know in your head. 9 times 3 is 27. 9, 10, 11, 117. So I get -117 over 5. Alright, the next thing we're going to talk about is absolute value equations. They're pretty much the same idea. We're just throwing absolute values in just to remind ourselves on absolute values. So, how is the absolute value of k and 3 connected? It is division, so we're going to multiply both sides by 3. So I have to cancel on that. So I get the absolute value of k equals -18. If you recall, absolute value is distance away on a number line. In this case, it's distance away from 0 on a number line. So is distance ever equal to -18? No. The example we talked about, I think, in the other video is we are driving from here to Memphis, or in my case, Nashville to Memphis. I would never say I go -300 miles. No, I say I'm going 300 miles. So this answer is no solution. Okay, back to same old, same old. Our 2 and y connected through multiplication, so we're going to undo by division, and we get 1.4y, or 1.4 equals y. Our r and 4 connected, division, and undo division, I multiply. And so r equals -36. Again, we can check all of these answers just by plugging back into the original, making sure both sides of the equal sign are equal. Alright, back to our absolute value equations. Divide by 3. 3 and the absolute value of g are connected through multiplication, so I'm going to divide by 3. We get 1.1 equals g, absolute value of g. So what numbers have a distance of 1.1 away from 0 on a number line? They are 1.1 and negative 1.1. Again, 9/23 and then are connected through multiplication. I'm going to divide. You could also multiply by the reciprocal. Just think it's easier to see it this way. I get 6 over 1 times 23 over 9. I'm going to do cross canceling. You do not have to cross cancel. 3 goes into 6 and 9, so 3 goes into 6 twice. 3 goes into 9 3 times. So I'm going to get 46 over 3. And 46 is not divisible by 3 because 4 plus 6 is 10, and 10 is not divisible by 3. Oh, and I messed up actually. Equals the absolute value of n. So what numbers are 46 thirds away from 0 on number line? They are 46 thirds and negative 46 thirds. All right, word problems. We're going to do a couple of word problems. First couple should be, if a number is increased by 1, the result is negative 4. What is the number? Well, I don't know what the number is, so I'm going to label it x. Increased by means plus. Result means equals negative 4. Again, how are x and 1 connected? Through addition, so I'm going to subtract. I get x equals negative 5. Two less than a number. Okay, this one's a little trickier. 2 less than a number. So I have the number and I'm making it 2 less. So I'm subtracting 2. So x minus 2 is another way to say equals negative 3. Again, x and 2 are connected through subtraction. I'm going to add 2 to both sides. And I get x equals negative 1. Karita ran the 400-meter dash in 56.8 seconds. This was 1.3 seconds less than her previous time. What was her previous time? Okay, so we're looking for her previous times. That'll be x. Okay. There's two actual ways to think about this. So I'm going to take her previous time, and again, less means I'm going to subtract. So x minus 1.3 equals 56.8. How are how are x and 1.3 connected? Through subtraction. So I'm going to add 1.3 and add 1.3, and I'm going to get x equals, carry my 1, 6, 8, 58.1. Does that make sense? If I ran a time 58.1 seconds, and then my next time I did 1.3 seconds less, I would end up with 56.8. So yes, that is reasonable. I guess we'll do that last word problem. The temperature of the summit of Mount Macefield dropped 17 degrees Fahrenheit between 4 and 11. The temperature at 11 was negative 11. What was the temperature at 4? So again, my unknown is 4, so I'm going to label it as x. So x is where I'm starting. I started at 4. All right, something happened between 4 and 11, and I ended up at negative 11 degrees. All right, what happened was I dropped 17 degrees. If I'm dropping something, I'm subtracting, so it's x minus 17 equals negative 11. So I'm going to add 17 to both sides. I get x equals 6. So I started at 6 degrees at 4. I dropped 17 degrees, which means I would be now at negative 11 degrees. Yes, that is reasonable, and that's degrees Fahrenheit. And I need to probably relabel that too. At 4 p.m., it was 6 degrees Fahrenheit.